Hi everyone, let's continue to 5.3, subtopic self-inductance. Okay, so self-inductance means the production of induced EMF in a coil due to the change of current in the coil itself. So if we change the current in the coil, it creates a changing magnetic flux. This is due to the changing in the strength of the magnetic field. So this change in magnetic flux causes induced EMF in the coil itself. Okay, to determine the direction of the induced EMF, we can use the Lenz's law. For example, let's say the direction of the magnetic field in the coil is pointing to the right. And as we increase the current, the magnetic field also increases. So according to Lenz's law, the induced current will flow in the direction to oppose the change in the magnetic flux. So the direction of the magnetic field that is induced is to the left. So using your right hand grip rule, your thumb point to the left, so the direction of the induced current is clockwise. Or if we draw the induced EMF of the direction is indicated by the dash battery. Okay, where this is negative and this is positive. So self-induced EMF or back EMF is proportional to the rate of change of current. So it's given that the induced EMF is equals to negative L di per dt, where L is called the constant of proportionality. It's called self-inductance. The self-inductance. So self-inductance, if we rearrange this equation, self-inductance is the induced EMF divided by the rate of change of current, where the self-inductance is equals to N number of turns times with phi, which is the magnetic flux passing through the coil, divided by the current. So the SI unit for self-inductance is Henry, okay, the symbol capital H. Let's see an example question. Let's say the induced EMF is 5 volt, developed across a coil. If the current flowing through change at 25 ampere per second. Okay, so we have to determine the self-inductance of the coil. So 5 volt is the induced EMF, and 25 ampere per second is the rate of change of current, di per dt. So it's given that induced EMF equals to negative L di per dt. So rearrange that. Self-inductance is induced EMF divided by the rate of change of current. So you get 0.2 Henry. That's the final answer. It's also given the self-inductance for one coil is equals to mu naught, where mu naught is called the permeability of free space. It's a constant value of 4 pi times 10 power of negative 7 Tesla meter per ampere. And N squared, where N is the number of turns, A is the area of the coil, divided by 2 times R, where R is the radius of the coil. The self-inductance for a solenoid is given as mu naught where mu naught is permeability of free space, 4 pi times 10 power negative 7, times n squared, where n is the number of turns, times A, where A is the cross-sectional area of the solenoid, divided by the length of the solenoid. Okay, so that's the end of the subtopic 5.3. Thank you for watching.